Yeah. No, later. You did some work as an engineer. 2 years with Airbus.
German Aerospace.
Aerospace. With A400 and the Eurofighter. Then he started his serious flying, commercial flying, initially on the A320 with Nicky Lauder's various airlines, which came and went. And then he converted to the A220 with Air Baltic, and he was still with Air Baltic. He then, this is during COVID. You did a.
I was in Air Baltic when COVID came in, and then.
You did an MBA. You did an MBA.
Yeah, I had to use my time.
Yes. And anyhow, he's now with Air Baltic, and we hand you over to its president.
Thank you, Hugh. All right. Yeah. Camera's on. Microphone might work at some point. Hello. Those work. So online you should hear me. When I move, I was supposed to use the microphone. And yes, it works. Great. Yeah. Thanks for the introduction, Hugh. As you can see, that's my name. And right now I'm flying the Airbus A220 actively in Air Baltic. And previously I flew the 320. So that's why, I got the request to speak with this topic today, highlights of the Airbus A220 from a pilot's perspective. And throughout the presentation, now, of course, then I can compare a little bit to the more familiar 320. And yeah, before we start the in-depth talk, I'd like to give you a brief history of the Airbus A220. Brief because the history is not that long yet. The Airbus A220, formerly known as Bombardier C series, was launched in July 2008. So that means, there are around 26 years difference between the 320 introduction and the 220 introduction. So some time to, develop new things and be innovative. The maiden flight was done by the CS100, nowadays known as A220-100. That was in 2013. And later on, the longer version, the 300 version, had its maiden flight in 2015. And that's the version I'm mainly flying, but it makes no big difference, just a few more seats in there. July 2018, then Airbus acquired majority stake of this project and renamed it to Airbus. So now we probably call it Airbus A220. Some say, it's a C series, it's a little Airbus or different versions. And with this program now, latest when I created this, there were 914 orders and 329 deliveries of this type of aircraft. And major operators in Europe are Air Baltic, where I'm flying, and Swiss. Swiss is operating both versions, and Air Baltic just the 300 version. This is mainly the brief history of the 220. And as I mentioned, the main differences you will see throughout the slide are mainly the result of 26 years of development in aviation. Just to get an understanding, the 220-100 has 125 seats, so it is definitely smaller than the available Airbus fleet. And the 220-300, the longer version, has 150 seats, so one could say, okay, competitor to the 319, because 319 has similar passenger capacity. Good. To take you through this talk, I'd like to take you onto a journey from Zurich to Hamburg. And along this journey, I will then present my highlights of the 220 as a pilot. And that's where you see the different stages. So before departure, we will have a few things and highlights to view. And then we continue and fly to Hamburg and have a look en route. Where are the highlights there? So first highlight, how does it work usually when we start our duty? We meet in the briefing room.
and do our flight preparations. And there already we have the first highlight, because we have to discuss and decide on fuel, how much fuel we take on board. And luckily I got the flight from Zurich to Hamburg with a 320 in the past, and now with a 220, so I could exactly compare the data, which is quite handy. And yeah, if we have a look at this is for illustration purposes because I had the real data. Of course, A320 classic engine option, it's a bit bigger, it's a bit older, but one can see the tendency, and nowadays even the 320's classic engine, of course, is still very popular on flying. So if you just look at the figures then, that there is a major difference just for the trip fuel. So just from takeoff to landing, we burn already half a ton less. Half a ton in money is quite a lot. And if we then add up all our fuel figures which are required, yeah, we end up with a more than a ton difference. And this, of course, makes economically a big difference here in the fuel consumption. And also when then usually the pilot's discussing, okay, this is a flight plan, this is a fuel, how much extra we want to take. So, and there we talk about, yeah, different numbers. So in a 320 easily going, okay, we take 500 extra. Or in a 220 taking 500 extra is quite a lot. So we are there with lower numbers. Yeah, but these are the illustrative real data. If you look at the average figures and numbers, we can say that the 320 nowadays with the Neo is burning about 4.2 liters per kilometer, and the 220 3.4. So there we have as well a good difference. But if you take into account the passenger capacity, then of course we should compare it more accurately with 319. Yeah? And there still 319 burns 0.5 liters per kilometer more. So same capacity, even with the Neo, same engines, but the 319 is unfortunately heavier because the 220, thanks to 26 years of development, is lighter in the overall design, new wings, and material usage. So we save fuel on that one. Yeah, and for the ones who like figures, 12.8% less. This was the first highlight in the flight preparation itself. And for, as I know, there are some engineers in the audience, so they like to dig deeper into the systems. I pull out a few images from the FCOM. I don't know, the ones who are familiar with the 320. This is from the 320. And just to show you some differences here. Here you have the fuel wing tanks, and the engines are fed by the fuel straight out of the wing tanks. Yeah, left wing tank for number 1, right wing tank for number 2. And there we go with the difference. In the 220, we not feeding it from the wing tank, we have a so-called collector tank. So the tank setup is a bit different. In the 320, we have outer, inner wing tank and the main tank. And the 220, we have just wing tank and the center tank. But we have additionally this collector tank, and it's fed from there. Operationally, it makes not a huge impact. It's just that, the design, the engineer said, okay, it's simpler that way. Then you can feed it and it's collected there. For the ones who like details, how does it look from the pilot's perspective? There you can see the first image outside my office, outside the flight deck. This is half a screen, and we can scroll through the systems, and this is how it looks with the fuel system. So it's quite easy interpretive for the pilots in the front. And now we prepared everything in the briefing room. We briefed the crew. We're walking towards the aircraft, and of course we have to power up the aircraft. So first of all, the aircraft needs some electricity, and this is our panel from the electrical system. How to say? It's quite nice that this aircraft does not require memory items. At least they propose that there are no memory items at all. And that means we just enter the flight deck, and the only thing we have to do is turn on those 2 batteries. Thereafter, it's all according checklist. That makes it pretty simple. Nevertheless, if we want to draw a comparison to the 320, it's quite similar. We have different sources of AC power generators per each engine. We have the external power and the APU generator, similar to the 320. And here as well, just the illustration again for the pilots are way, I would say, simpler, bigger, and straightforward. If some system does not want to play with us, it's immediately seen. And yeah, this is about electrical power, where we start up the flight deck, and then finally we are there. This is the office. Here the version with head-up displays, it's an option, so not every airline is opting for the head-up display. But I think you can straight away see the major difference to a 320. We have big screens and colorful screens, and we can modify all the screens. So I will go through the next slides and you can see what we can display there, which is very handy operationally. Of course, okay, you need an information, you can display it and you can place it wherever you need. So yeah, modern avionic. And just to draw a quick comparison, this is the one you're familiar to. Usually everyone knows the 320. I would still call it a modern flight deck, even if it's from the 80s. But yeah, you can clearly see the major differences. And also where I always still wonder with the 320, we have a quite big screen, well, but the artificial horizon is still small. I mean, I don't know if you need it like this with a whole screen. But, of course, this enhances situational awareness about your attitude in the air. So now I zoomed in a little bit. These are our major instruments, the primary flight display and the navigation display. And as I said, you can see here the artificial horizon goes along the whole screen. So it doesn't matter where you look at it. You definitely straight away can see, okay, how am I in space? And below then you have your horizontal situational indicator. That's this one, where you can see navigational wise, okay, where you are in space, in a lateral sense. And you have some more icons later on here, which I will describe, which are very handy. But on the other hand, yeah, navigation display with a vertical situational display. I know the 350 has it now as well. But at this size of aircraft, I would say it's a rather innovative approach. And we, not there, there we go. These are then the middle screens, so we have in total 5. These screens we can modify as we like. One fixed screen size is this one. We call it in the 220 Engine Indication and Crew Alerting System, ICAS. That's more familiar with the Boeing side. In Airbus, it's ECAM. But the result is the same. So we have our major engine instruments, and if we have some issues or some non-normal activities, it's all displayed here. This screen you can set here as well, depending on the airline procedures. Okay, pilot flying has it, or always the captain side. And all the other screens, we can modify as we like. Yeah, here you can see right now the navigation display, and this is also the navigation display, just zoomed in, so that we have a real awareness. Okay, where do we taxi? Which parking stand do we have? Because yeah, how often get we lost at major airports? We have, of course, our charts. Sometimes it's still tricky, and this one is an advantage that we have a direct position on the screen, on the map where we are. And actually, this one we can also, of course, display on the whole. Next one you can see here is a presentation of the FMS route page. This gives you, when you program your route, well, program is in this one easy, upload. I remember in the 320 when I flew it, I had to put in all the points, so program each point in the route. Here, just press one button and the route is there. Thanks to data link nowadays. And right there at this screen, you can see the data link module. So where we can communicate with the company, with maintenance, where we get all the data. And here in front of this display, you can see the thrust lever, which is also another highlight I'll come back to later. But when we talk about the screens and different setup, I have a presentation here, which is in the FMS perspective, a normal setup. Here, the route page and the performance page, so that the pilot flying has the performance side and the pilot monitoring the navigation side. But here you can see the checklist page. So we are not using any paper checklists or QRHs or sticked checklists on the table. We have only electronic checklists, which is pretty nice because it has sensed items. And that means we don't tick the box, because we just switch something and then it's automatically sensed in the electronic checklist. And as you have seen previously, the system page. So again, here's a representation of the flight controls, and here the electric page. So this is an introduction to my flight tech, to the office. Again, for the engineering interested ones, a bit deeper to the systems. Yeah, here's the overview. We have 5 display units, and then of the main board here with multifunction keyboard and course control panel. This is very handy, and I know it's in the 350 as well, but not in the 320. To modify and go through all the information on the screens, it is easier, way easier to have a trackball. And there we have one, so we can control everything. We can jump with a trackball from screen to screen, and like with a mouse right click, we can then adjust it. And yep, another highlight systems wise, you might have seen it or recognized in the there in this panel above the screens. Usually here you have the flight control unit for the autopilot, and now we have here in this one this panel, which provides us the possibility to adjust communication frequencies, the weather radar on, off, TCAS, the mode setup, so all right in front of us. So we don't have to change our view down and look there, how to set it up, or yeah, so we can just turn it here. But when I talk about communication, we have multiple ways in this flight deck to change the communication frequency, for example. I remember in the 320, depending on the age of the aircraft, and you want to change the frequency, you turn sometimes quite a while to set the right frequency. Newer ones are quicker, so that works fine. But on this one, of course, here, the same idea, so with the turning knob, but we have also the opportunity, do I have it later? Yes, there we go. We have, again, one of our screens set up this time with a communication panel, and we can just type it in. So while the ATC gives you the frequency, you type it in, and then you just put it in there, and then it's set. So you don't have to turn and remember the frequency and so on. And if you're very fancy flying every day the same route, then you can pre-select the next frequencies and you just dial through it. So yeah, hopefully you're not we're not flying every day the same route, but the feature is there. And yeah, so now we were in the flight deck, we set up everything, route is uploaded, performance is set, communication is set, and then yeah, we want to start the engines. Before that, we do our checklist. Before start checklist, as I mentioned, we have an electronic checklist. We just open it, and the gray ones you can see here are sensed. So before the doors are not closed, we cannot continue. We cannot complete the checklist, and then that's why then of course we have to wait for it. Here beacon is sensed as well. Okay, beacon is not on yet. We switch beacon on and it's automatically green and ticked, and then you can continue and tick the ones which are not sensed. Checklist done. We can start the engines. Next highlight, I know the 320neo, 319neo, all the neos have now also the opportunity to get a Pratt & Whitney geared turbofan engine. Nevertheless, here it's the standard one, came from the beginning on with this engine. And this, of course, leads to less fuel consumption, which we already had in the briefing, and less noise. Of course, I know that then plays a role in the neos as well. Yeah, to draw a difference, we have a bypass ratio of 12, and the 319 even 12.5. So there, the bypass ratio is even a bit bigger. But overall, these engines have their flaws and challenges, as everyone can follow in the media. And unfortunately, half of our fleet is on the ground as well. But if it's running, it runs. And it runs economically and quiet. And the startup of the engine takes just ages. So in comparison, we need 1 minute and 45 seconds to get one engine running. So that means if you want to catch a slot, you can take it into account, push back a bit earlier, start the engines earlier because it takes a while. As compared to CFM engines on the 320, the older ones, they run after 1 hour, after 1 minute, roughly, and then you can go. So you sit there and wait. On the other hand, the starting procedure, again, on this one, fully automatic, easier cannot be. I mean, even if you have non-normal engine starts, such as you need APU is not working, you need external air, or you start one engine with the bleed from the other engine, it's all the same procedure for the pilot. So no big difference there. In a 320, I remember, okay, there were some differences. Okay, if you do this startup procedure, you have to adjust these and these things. And then the 220, you just do always the same. Pretty simple for the pilot. Yes, so we started our engines. I don't know if you might have heard an Airbus 220 starting the engine. It's quite significant in Riga. When we start the engines in the morning, it has this wailing sound at the beginning when you add some thrust. Pratt & Whitney says it should be solved around next year. But so far, everyone who's living close to an airport with a 220 starting up the engines, they know the sound. Quite typical for that one. So, as I said, we started the engines. You have some more comparison figures between 319 and 220. As I mentioned, same seat capacity, same speeds, but of course, due to different material choice, the 319 is heavier. Nevertheless, okay, a bit more fuel capacity, therefore it can fly further, but that's specific to the 319. I know the 320 is not flying as far as the 319. Nevertheless, I have to say from experience, with the 220, you can operate economically, efficiently for half an hour flight, like Riga-Vilnius, or up to Dubai, 7 hours. Just last weekend, I flew to Dubai. You can spend 7 hours in this aircraft without a problem and arrive with a fuel margin safely. And yeah, fly with that aircraft up to 3,400 miles. Then, as I mentioned, we have this detailed ground chart, which helps again moving around complex airports. Toulouse might be not that complicated. I don't know, first time here. But if you approach Paris, Amsterdam, Frankfurt, they are quite interesting if you're new to the airport, and then that helps. The same there, we have also some supportive or proactive avoidance systems like the TLOF system, which says, okay, you're on the wrong runway, you would try to start on a taxiway or whatever. There are systems in place to, like on a 350 as well, I think. 320, maybe you have an option by now. But yeah, you can see it visually already there. Okay, this one way is chosen, this one we take off, or the other ones, the aircraft will remind you that you're on the wrong way. That means we made it now after engine start. Again, checklist reading, and we made it successfully taxi-wise. We did not get lost. We made it to the holding point. And then this little highlight here, our thrust lever. Everyone knows in a 320 thrust lever is nice, click, click. So we just move the thrust lever into notches and then it stays there for the remainder of the flight. There were always some complaints in the past, okay, but situational awareness, so where's my thrust? So you can cope with it, that's not a big deal. But it is nevertheless, I would say, a benefit and enhancement that this thrust lever is moving. So whenever you want to know the thrust setting, of course, you can look onto your instruments. If you're experienced, you might recognize it by sound. But on the other hand, you just look to your thrust lever and it will be in the right position where the thrust is set. Also, when you want to disconnect the auto thrust, you don't have to first, in a 320, I remember always first get the thrust lever to the right angle so that it matches the thrust setting, and then you can disconnect the auto thrust. Here, it is always at the right spot. Of course, then, if you advance thrust on the takeoff, there is a different procedure because you cannot set the click to the right notch. There you move it forward and then you will feel that the thrust controller will, or the aircraft takes over and moves the thrust lever to the right position. I will have a short video when we take off and then you might focus on that one and you can see that I move the thrust levers forward and then it moves on its own to the position which we have set in the FMS beforehand. Good. Movable thrust lever. There we go. We take off in Zurich. As mentioned, I take you onto a journey. Thrust lever move forward, leave it, and the thrust lever move it further. So now the thrust lever is set at the right position. You see these colorful screens, especially in Zurich with the Alps around, and then we take off. Yeah, that was a normal takeoff in the Airbus A220. Very quiet, not really movement. I know in the Boeing sometimes you see more movement on the yoke. Yeah, there's not much to add there. The highlight was the thrust lever. Thereafter, as I showed you earlier, this panel for the communication setup is very handy. You look outside, you take off, you change frequency, you just press a button without any change of view. And you have your full situational awareness, you have a vertical situational display, and you have the terrain all around you. So that's very handy and enhances safety. But now we are flying, we are in the air from Zurich to Hamburg, and now we can deal with some other highlights in cruise. And from a pilot's perspective, or also passenger perspective, because as pilot, unfortunately, well, we sit from time to time in the cabin as well. So I would say there are also some highlights. Here you see the cruising level versus cabin altitude. Normally, as you can see here, the usual cabin altitude is between 6,000 and 8,000 feet. We all get used to it, so that's not a problem. But of course, for an average human being, it's nicer if it's a bit lower. So a bit higher pressure. And that's what is possible with the 220. Usually we fly with the cabin altitude below 6,000 feet. So it feels more comfortable for the passengers. Just recently when I flew, I saw we were at 36,000 feet, flight over 360, and it showed 5,800 feet. So we were below the average from the original Airbus and Boeing. Cruising flight level, cruising altitude. Okay, we fly as high as the Boeing 737, 320 a bit less. I would say it makes not a big difference, but of course, economically wise, the higher you fly, the less fuel you burn, the more efficient it is. So flying 410 is also quite nice. If you have some weather in summer, then yeah, you can fly above it, and others have to circumnavigate the cities, the clouds. Therefore, our max data pressure is possible 8.8 psi for the ones who are familiar with some pressurization systems. And yeah, this is mainly the result of the extensive use of new materials such as aluminum, lithium in the fuselage. So we talked about the pressurization, and if we talk about, yeah, pressurization, air, then usually as well, we talk about some air conditioning for the engineers in these areas. Here you have a drawing, a picture, how the air conditioning system is usually working in the 220. There I would say there's no huge differences to the 320, but as I'm not expert in this field, you can see just here how the system is connected. So usually it's the bleed air system coming from the engines, extracted the air, and then in the case of 220 go through a flow control into the packs, and from the packs then it is distributed to the mixed manifold. Okay, so we have the hot air fresh from the engines going towards the through the packs to the manifold, and then it is connected with the used air but colder air as well from the cabin, and this way you can heat up all compartments. So we have different control over the flight deck because we usually don't like it that warm as the passengers, and then you have a forward and aft cabin section which you can heat, and the forward cargo is heatable as well, especially when you have some animals on board. They should be in the forward hold, otherwise it might get cold. How does it look again from a pilot's perspective? This is our air synoptic page, and you can see exactly here, okay, how is the system connected and distributed, and flight deck, as you see, usually it's colder than in the back. And the cabin crew, so we set usually a temperature, and then the rest has to deal with it. The cabin crew has some margin, so they can adjust the temperature by ±3, but not more. So if they want to have it then warmer in the night, especially, or colder, then they have to call us, and we can give them more freedom then again to adjust it. Air conditioner in the cabin, you can see here already the next highlight, the cabin layout. So we're used in a 322-33, so 6 appraisal, and smaller ones like the Embraer has 2 and 2. Bombardier decided on a 2-3 configuration in a normal setup, which leads to multiple advantages, I would say. First of all, we got the feedback from passengers as well. If you enter the aircraft and you look at the cabin, it looks roomier, spacier. So feeling-wise, you have more space. Funny enough, it's not just feeling. We have more space in the sense of we have larger windows. So we have the largest windows in these size of aircraft, and those 2 and 3 seats are wider than a normal 320 or 737 seat. I just read a study from Airbus that they made with the seat width. So, and they suggested, okay, if you increase the width of a seat by just 1 inch, it improves the comfort, the sleep quality from the passengers a lot. And they suggested 18 inches seat width. Well, we have even more, 18.5. And the middle seat, on this side we have a middle seat. I know it's usually no one wants to sit on the middle seat, but in this one, the middle seat is even wider. Just to give some, I mean, it's just ½ inch. On the numbers, it's not much. But as a passenger, apparently, according to scientists, they feel it. Yeah, that leads to this configuration, wider seats, a wider feeling in general. And is it the next one? Yes. Here is another one, just as a little hint, if you fly next time the 220 and you have a rather bigger suitcase, this one, if you enter on the right-hand side, is a bit smaller than on the left-hand side. So if your luggage does not fit on the right-hand side, try it on the left hand. It works, really. In general, they are quite roomy and quite big to fit in the suitcases. But regularly you see the passengers trying to squeeze it there, and you just go there, put it on the side, and it works. What else is very nice? In the cabin for the passengers, we have overhead those little screens. Those screens are not big, but you remember maybe the old times when flying was in every seat was a screen. And I mean, still with Turkish Airlines, there are some airlines where you have screens in every seat and you can see long haul, of course, everywhere possible. But here we talk about a short, medium range aircraft, and we have those little screens on top. So every passenger can at least follow up the routes, where we are, and some advertising, of course. But which I would say is a highlight, why I don't know if every airline is using it, but Baltic is an hub and spoke carrier, so Riga is the base where we then have connecting flights. So instead of, I just experienced at Lufthansa, they read for the next 10 minutes some connections, and here you just display the connections, including the gates, and yeah, it's quite handy for the passengers to always have a look. Yeah, so these are my highlights from the more passenger perspective, but also as pilot, of course, if I'm sitting in the cabin, it feels more comfortable. Back to the flight deck. Another highlight I'd like to introduce you is something with the 350, of course, is known. But as I flew 320 before, it was a highlight for me. We have this emergency descent mode button. Just for your understanding, on a 320, we had 11 memory items to do if we have a sudden pressure loss. So hopefully mask came first so that we can deal with the rest of the 10. Yeah? If not ideal. But in a 220, mask on, press button. And if I want to get it a bit faster, spoilers out. But that's it. And from that moment on, I can breathe in for nice fresh oxygen and wait if I want, or deal with the issues. It will descend automatically down to flight level 150, levels off there, and continues the routing. So this mode does a lot of things, sets the emergency squawk, so that even the ATC knows, okay, we have a problem in case we did not make it on time with the mask, but at least push the button, then we get to a safe area where we can continue to work. So yeah, down to 15,000 feet, one button, which is very handy. When we are already flying, of course, nowadays, out of flight, the autopilot is the system we use the most. I put on here some extracts of the FCOM. This is our FCU. And what I'd like to highlight here is every Airbus engineer, even or a pilot, everyone who gets in touch with Airbus has heard or knows about the flight modes, maybe open descent and managed descent. So for the pilots, it's a simple method to adjust, vertical profile. So they pull or push, and that's it. And the 220, even it is now called Airbus, you can see more the Boeing philosophy. So Boeing says, okay, we have flight level change, vertical speed, so those lateral and vertical modes. And for the colleagues who transit first time to that type, also, especially from the Airbus, they struggle with it because you can have a lot of combinations of modes to control the autopilot until, yeah, you can somehow see draw a comparison. Okay, look, if you activate VNAV, it's managed. So like in an Airbus 320. But nevertheless, there is a difference. One has to get used to it. But at the end, it works very fine. What else we have here? So from the flight control unit or from our manual inputs, we still fly manually from time to time. We then adjust the parameters, and the next time we see how this works and how it's displayed. It's the display here. I will come back in a few slides. So we made our journey now from takeoff, climb, cruise. So you experience the cabin, and now we're descending, hopefully not with the emergency descent mode, but normal descent. The next highlight is that this aircraft, as we saw, was designed in the 2013-10 area. So GPS was available. So literally this aircraft is designed for GPS, which is, well, nowadays not ideal because we fly in a lot of areas where GPS is not usable at all. But you can see the difference. Like in a 320, when it was initially designed, GPS was not the common navigational source. But this one is purely designed for that. That means, as a pilot, you have usually different options how to approach an airport. Conventional ways, such as ILS, is still nowadays the standard way of approaching an airport because usually the ATC provides you with that. But there are more efficient ways to approach an airport. And these are RNP approaches. And if you get this authorization required, so a specific approval, because your aircraft is capable of providing the performance to do these approaches, then you can do even more efficient approaches, short approaches, curved approaches, more efficient. So what does it mean? You can, I just put up here a picture which shows you the differences for the ones who are not regularly sitting in a flight deck and flying. So very conventional, if you talk at the beginning without any GPS source, then we just flew zigzag to get from A to B, which is not very efficient. So with the introduction of GPS, at least, okay, we got some random waypoints where we can fly from waypoint to waypoint. But if we then improve the performance, okay, it works like this. And now, let's say the final stage where we are currently is the RNPAR approach, where you can do a curved approach. So you don't need a lot of points to get to your destination. You can just program a curved one. And this is then the consequence out of it, because we talk about efficiency economically. So this helps us to do way shorter approaches. You can just imagine when you're a passenger with a window seat, sometimes it can happen, visibility is great. So you can see the airport where you want to fly, because the landing direction is southbound. You're coming from the south. So first of all, you fly past the airport, say, hello, there's the airport. And then in the next 10 minutes, you fly around and you end up at the airport. Because this is a conventional ILS here. You first have to fly out for around 10 miles. Then you turn in, capture your localizer, and then you fly those 10 miles back the runway, which is a waste of time and fuel. So with this new technology, we don't fly that far out. We just do a curved one and end up roughly 3 miles away from the threshold where we are wings level, which looks quite cool if you're in the flight deck and there's the runway and you're still turning. But main aim of this is save a lot of time and fuel burn, of course. And this is possible with this aircraft, and that's our standard approach into Rücker, for example. But other airports are providing this, and with our aircraft, when we get it, usually ATC nowadays still have a problem with it because they cannot sequence it properly. But if we get it, we can save easily 10 minutes time. How does it look on a chart? Yeah, you can see here this curved approach. So we don't have to fly out here and come back. When we're coming from the north, we just turn in, and this is about 3 miles, the threshold, 3.5 miles. As we're now flying, and ideally then at the end at least a little bit of manual flying, then of course we have to use our flight controls. So for the interested ones, for the engineers, we have flight controls such in a 320, same control surfaces, no big changes there. This is our flight control system. So there we have a difference. Here up there, for the ones who know it maybe, this is the 320 layout. So you give your inputs, doesn't matter if you do it on a side stick or with the autopilot, end up in the same computer. And then this computer says, okay, move the surface. In the 220, we have something in between. The remote electronic unit, the REU. This one calculates, so you get the input from the flight control computer, and that calculates, okay, how much do I have to put in the hydraulic actuator to move the surface? Why do I talk about this? Because I'd like to highlight the differences in flight modes. Because the 320 is known, okay, we have these flight modes like normal law, alternate law, and direct law. So, yeah, if there are pilots in the audience, you might remember. But this is if your systems get degraded, you change your flight mode. So the flight law in the out-of-flight system is changing. In a normal law, that's how we operate daily. We have all limitations covered by the aircraft, so we cannot really destroy it or get over limits because the computer says, no, stay in your envelope. Alternate law, because of some system degradation, is already degraded, so you cannot really, so now you have to pay attention more to certain limits. And yeah, if you end up in a direct law, in a 320, it's quite a challenging one because no autopilot anymore, so you have to fly manually, which is usually not a problem to fly manually with a 320. But in a direct law, it feels completely different. You have to trim yourself. So it is a challenge, and if you get in this direct law, some more problems happened before, otherwise you wouldn't get there. So it's quite a good workload. And in the 220, you don't have these specific laws as known on a 320. You have the normal law, of course, but then you have direct laws with a different setup. So because we have these REU in between, and we have an alternate flight control unit, we can adjust the direct law into 3 different stages. So that means various things will then disappear depending on which direct law you are. But from experience, I mean, luckily just in the simulator, the direct laws on the 220 are way easier to handle than in the 320 because you still have good amount of support. And what else is different handling-wise? On a 320, when you fly the aircraft, even when you fly manually, you have auto trim. So you don't have to deal with the trim. Trim means that the aircraft is set in a conventional aircraft for a certain speed. And it doesn't matter what you do, you change your attitude, but if you leave it, then it returns to your speed. So it's always trimmed for that setup. In a 320, it doesn't work like this. So if you come from flight school and fly first time 320, it takes some time to adapt because on a 320, you add thrust, and in a conventional aircraft, the nose would rise up. In a 320, not, because it has auto trim, which means then it changes the trim so that your attitude stays. Which is confusing if you're conventionally used to flying a smaller aircraft. But of course, it reduces the workload because even while flying manually, you don't have to trim all the time. You can just look outside the window and maneuver your aircraft, and it keeps the attitude. So then changing to the 220, again, it is conventional. So I have to trim while I'm flying manually, which is easier for the students because they come from an aircraft where they had to do it anyway. But that means as well, okay, they used while manual flying, they have to trim, and this results as well in the flight control system that, yeah, it works with it, and you as pilot, you have less challenge to deal with the changes of flight control, of the flight laws. I hope I did not lose everyone here, but this is a major difference in actually flying the aircraft and the handling qualities. But yeah, if we talk about flight controls, you see here we have our control surfaces, and they have to be moved somehow. And this is usually done with hydraulic power. What a surprise. Also in the 320, as in the 320, also on the 220, you have 3 hydraulic systems. In the Airbus 320, it's usually named by colors. You have blue, green, and yellow. Well, the 220 was not that creative. They said system 1, 2, and 3. Where system 1 is attached to engine 1, and system 2 to engine 2, and 3 is the backup system. Or not the backup system, but the third system, as we always want to have 3 hydraulic systems in case one is leaving us, does not want to work with us anymore, then we have 2 remaining. And I guess everyone knows this distinctive sound of the power transfer unit, the PTU on a 320. Everyone knows it. In the 220, we have a power transfer unit. We have a PTU. You can see here. But the design is completely different. And that's why you usually don't hear it. And if you hear it, it's very quiet because the dimension of the PTU is way smaller. Reason for that, in the 320, the PTU, the power transfer unit, is there bidirectional. So it has the function if hydraulic system in the 320, the second one, so which is the yellow one, is powered with an electric pump on the ground to open the cargo doors, then the PTU automatically gets the pressure onto system 1, onto the blue system, and that makes the noise. So the PTU stops when no hydraulic power is needed. But the issue or the design is there that both systems, the yellow can power blue and blue can power yellow as a backup system, both directions. In the 220, it's not the case. Because in the 220, you have 2 pumps on the second hydraulic system already, so you don't need the PTU to have a backup pump here. You have an engine-driven pump on the second and on the one, and alternatively on the second one, you have an electric-driven pump. Just electrically driven pump. So the second system does not need a backup. But the first system, yes, it has the engine-driven pump. If this fails, we have the PTU. So then we get the hydraulic pressure from the second system transferred to the first system. Fair enough. Now, why don't we hear the PTU usually in the 220? We start engine number 1 first. So engine 1 is running. So in the Airbus, now the PTU would start and to power the other system. But we don't need that because the second system is already running by electric. So that's why then, we start engine 1, engine 2, you don't hear any PTU. And on the shutdown neither, because we have an electric pump to work with the cargo doors and anything else. That's why I wanted to highlight the hydraulic system a bit, because this is a difference, as everyone knows, this PTU noise. Yeah, this is the 220, the 320 system. Green, blue, and yellow. I mentioned this. Good. Then we were on our approach. We talked about, okay, flight controls, handling qualities, and now we get into the final approach, where I prefer to fly manually because some fun for the money should be there. And there I'd like to show you some more highlights. In the 320, we have a flight director. It's this one. Yeah, we have a green cross and we place our yellow amber quarter there and follow it. This does not take into account any wind changes or so. So this is a real flight director. And in the 320, you have the option to take the wind into account with a flight path vector, so to say. But you use it only for specific approaches, not for the standard approaches. Then the highlight or the new thing for me on the 220 was we constantly fly with a flight path vector. We don't have a original flight director. So you can see here, this is where we should be, and then this is where we are. So we put the flight path vector always on the flight director queue, and that means we take all the time the wind into account. Every fluctuation in turbulence is recognized in our flight director queue. So it makes it easier to stay on track because you just have to follow that. And another one, here you can see this little chevron and this bar there. Not many colleagues using it, but it's very handy. And the 320, when you fly out of manual thrust, you always have to have a look. Okay, so how much power do I have in my engines, and adjust it while flying manually. In a 220, I lost to look at the instruments for the engine because I have this energy queue. So this one shows me immediately, okay, there's too much energy in my system for the flight path I want to fly. So I see, okay, too much energy there, but I have to keep my flight path. That means thrust back. Thrust back to bring this aligned with that one. So that's very simple information, so to say, in my little view where I'm looking at it anyway, to have a control over the thrust. And I don't have to look, how is my thrust setting? And yeah, this is very handy. And I realized when I was sitting in a 320 again that I was not looking at the engines and was, confused, irritated that it doesn't work properly. The thrust level had to be changed. So this leads to less workload and ideally a smoother approach. And as we are now coming to the end of the journey, so we did our briefing, preparation, starting engine, taxi, takeoff, cruise. You saw all kind of my highlights I'd like to share. And at the end, there's usually the approach and the landing. So there we go, another video. So now we're coming to the end of our journey. You see the before landing checklist quickly done on the screen. And runway is ahead. Still with automation on. You can see here autopilot, autothrust. So autothrust and autopilot are now disconnected. So now I try my luck and try to get the aircraft on the ground safely. And all those fancy screens. Again, you cannot see much movement, but we're getting closer to the runway. There we go. We're back on the ground. Thrust reverser, and yes, I have to be honest, it was not Hamburg. It was Amsterdam. But at the end, it's a tarmac strip. Anyway, this was the short journey from Zurich to Hamburg, including all the highlights from my perspective. Thank you. So I guess the plan is now, I don't know, some questions maybe are there, then we can go through these and then, or Hugh, do you want to continue first? No, question first? I don't know if there are questions, it might be there. Okay, maybe for the online audience, I just hand over the microphone? Yes. Okay, good.
Yeah, the emergency descent mode that you mentioned, which takes you down to flight level 150, I think you said. Is that somehow connected to the FMS to take into account high terrain, i.e. terrain over flight level 15?
Yes, it is supposed to take that into account. Luckily in Europe, actually, there's only the area where it would be too high terrain, but that takes into account and would level off higher. Yeah.
Okay, thanks.
Anyone else? Sure. Yeah. Yeah, I like this.
Obviously, I love your curved approaches.
Yeah.
I remember trying to get programmed into would you believe, the TriStar in the mid-70s, but that's a long time ago. But by doing visual approaches, I always said the most efficient approach is a visual approach.
Absolutely.
And you do your curved approaches on visual approaches.
If you're absolutely right. But the only issue is for visual approaches, you need the meteorological conditions for that. So you need to be visual. I know there are some interesting colleagues who say, visual, and they don't see anything. But with the RNPAR approach, we can fly without visual reference to the ground to a proper minimum. And this is then the difference, I would say, to visual. Otherwise, I agree, visual approach is favorite.
In which case, I hope that will come in very quickly, because at the present moment, many pilots are saying, companies say you mustn't do visual approaches because we see pilots trying to do visual approaches. They don't work out too well. So you must stick to almost the ILS approach and the RMP, which takes you miles out. And again, which is costing a lot of fuel and noise and whatever.
True. I think there are multiple aspects to this point. Visual approaches are, I would say, one of the more challenging ones. Yes, you need more training and more routine in that. The issue is the training time is usually limited. Then the pilots are lazy. There's a group of lazy people. So the easiest way after especially long flight is just do the standard routine one. You press a button and it works. If you're not as motivated and keen as young colleagues, like, I want to do visual approach, and the boss on the board says, okay, we can do it, it's sometimes difficult to get to visual approaches. But of course, I agree, some airlines restrict that as well. Luckily, not in my company, but yeah.
It's interesting, it's a long time since I operated in the States. When I first started going into the US, a lot of time was visual approaches. Going into New York, they say, have you got the field in sight? Yes, cleared visual approach. That was happening all the time. I don't know how often it still goes now.
I think another aspect is the traffic. I guess at this time, there was way less traffic. Nowadays, example, London Heathrow, you get in there, you cannot do a visual approach. You would screw up the entire traffic there because you have 2.5 miles, one in front of you, and 2.5 miles, one in back behind you. And if you're not keeping your speed, and you piss off the ATC, then you're the one who's leaving the zone and try to figure out where to land. So there are some cases where you cannot do visual approaches. But especially as you said, smaller airfields like Tallinn, for example, if there's a chance, I always do visual approaches because it's the easiest way. There's no traffic, they clear your visual, and you do a short turn, and then you're in, save a lot of money. Yeah. Everyone has to be proficient and train for that, and yeah.
You're absolutely right, Jens, about Heathrow. Having said that, I can promise you in the past, and I'm sure at the time now, if the traffic is all right, I always say, can you do a visual approach? And they will let you. Well, they did in my day.
Yeah, if the crew is able to encourage each colleague, it works. But I think on the other hand, maybe we are so many pilots now with different backgrounds. And now, as an example from Air Baltic, we have our pilot academy students. They first of all have to get used to the aircraft. If you put them on the visual approach, it will be a mess, that's for sure. Yeah, there needs more training and more maybe focus on encouragement on that one. But at the end, visual would be more sufficient. Yeah.
You're right. Yes.
But I do like visual approaches. Yeah.
Do we have anything online? Oh, sir. Hello.
Thank you. A question. Many, many years ago, when GPS was being introduced to the A320, well, we were a little bit late. And we have queries from an airline that was planning to use RNP approaches in the United States. We said, look, this is a problem for us. But we found out, in fact, that the aeroplane without the GPS had the required
Needs the
navigation
requirement.
performance
Okay.
in the DME environment.
Yeah.
Have you found anything similar in your area? Because you're suffering badly from lack of GPS.
True story, yeah. As I mentioned, I just flew to Dubai. Literally after takeoff, GNSS all off, because then we flew conventional. Because there's no point in using GNSS when you fly between Belarus and Kaliningrad. There's no point in using GPS through Turkey along the Ukraine border, and there's no point in using it over Iraq, because you have spoofing, spamming, the whole route. So if you turn it on, you get all the time your warnings, ADSB out, and a lot of malfunctions. So you turn them off and use conventional navigation on this aircraft, which is designed for GPS. So therefore, even I think it was over Turkey, when you don't have that many VOR-DMEs placed, then the aircraft has difficulties and starts to tumble right and left to keep the route, because it was not designed for proper use of conventional navigation if it's too far out. So we get back on heading mode and adjust heading ourselves, which is a pity in nowadays time with this modern aircraft. But yeah, that's the way it is now. Yeah, GPS spoofing is quite present in this area. Yeah.
You can unmute. Aravind?
Thank you. Thank you for the presentation, gents. It was very nice. So, yeah, I could see the design, the whole system design is kind of a blend between Boeing and Airbus in many different aspects. So from a flight control authority perspective, I would like to know if the philosophy behind, was it more manual authority oriented or more AP oriented? Because A220, A320, for example, is more, Airbus philosophy is more AP based. It gives more, it depends more on the automation side rather than Boeing's philosophy of manual authority control. So I would like to have your perspective. Do you think it's more manual or AP in terms of flight envelope protections and over running of flight control protections?
Yeah, as you mentioned, it's, in many aspects, it's a combination of Boeing and Airbus. But as you ask for flight protections, flight envelope protections, autopilot focus, this aircraft is more focused on computer automation, flight envelope protection for sure, because this is the trend, and that's why the pilots operating this aircraft, they can operate easily without any manual flying. In the 320, you can engage the autopilot at 80 feet. On a 220, well, at 400 feet, so a little bit more manual flying. Straight line, it's not that easy, that hard. But from that point on, you can leave it completely on automation, and the aircraft works totally fine. Especially then when you have, as it's designed for a program, the RNP approach. As soon as you're cleared for RNP approach, it can be 100 miles out. You can just press approach button and watch it. And it will bring you down to the threshold. 320 doesn't work. I made the mistake in the simulator. You first have to get in a proper range to the runway track to activate the approach mode. Again, something learned. But yeah, that's maybe goes to your question. So this aircraft is definitely designed for automation use. And the only manual gig is that we have to use the trim while flying manually. I guess this is maybe then from the Boeing side.
Okay, so in terms of alpha protections, is it same like in A320? Like you have alpha prot, alpha floor, all these things. So is it something similar to that? AP
It is-
disconnects. AP disconnects just after alpha prot, or?
It is similar to that. I cannot answer directly, okay, how it is exactly, but the wording might be bit different. But at the end, yes, you have these alpha protection, and you have some margin, and the autopilot. If you get into this area, the autopilot would react and saves you.
Okay, it disconnects basically, or?
No, first of all, automatically it tries to get out of it, so it would.
Okay.
If you're getting too slow because you have a high pitch, then it would lower the nose to get out of the speed range, and it would scream at you.
Okay, because I remember like in A320, just 1 degree plus a alpha prot, it gets disconnected, kind of autopilot.
I cannot confirm that. I don't remember that.
Okay.
But I believe you. So it might be the case, but in the 220, I am not aware that it will disconnect. It will just say, "You idiot," and I will save you.
Okay, thank you so much. Thank you.
Welcome.
Thank you, Renzo. I don't want to waste too much of your time.
As long as the interest is there, I'm happy to answer, as long as I can answer the question.
Do you have the brake to vacate option in 220?
No, I know brake to vacate is in a 350 standard, and the 320 is it an option? No. Okay, the 220 has no brake to vacate. We have low, medium, and high. Usually we land with medium to heat up the brakes, and then we have to figure out which exit we take on our own. At least something we have to put some brain in. Huh? But I wouldn't say that it might be an option soon. I mean, Airbus tries to harmonize all fleet models, even the 220. So we will see what will be added, because I guess it's at the end just a software update. Any more questions online? No one? Ben?
I was just going to make a slightly historical thing. I'm glad you mentioned DME, because if you've got a DME in line with a field, if you have a simple table, you can do a constant angle approach very easily.
Yeah.
And that's what worries me about taking DMEs out, because DME is a very good backup. You can do a very good constant angle approach.
I agree.
With the DME.
Yeah, I still use the DME. I mean, I don't have to, but it's always a handy tool to have situational awareness. Okay, how far am I at? And which altitude should I be for the descent management? And still, I would say most of the airports have at least a DME. But yes, of course, for the approach design, it is reduced to ILS RNP approach. So all those VOR, DME, NDB approaches, they are all more or less gone. So with my students, I have some difficulties to practice NDB approaches.
But it's even useful in a visual approach if you have a DME.
Yeah, absolutely. Yeah, exactly. DME is helpful, and well, I guess the idea behind it is that by removing the DME, you can get the distance with the GPS as well. But unfortunately nowadays, not in the spoofed area. So I agree with you. It would be nice to have at least the DME maybe a bit longer. And yeah, because the GPS is not flawless.
I hope they don't get rid of them too soon.
Yeah.
So
good. Then thanks for the questions. Thanks for the interest also online. And then I guess Hugh, you take your part again.
Like a presence here. Probably don't need that anymore. Is that right?
Yeah, those microphones should work.
So we're back on these microphones, Alex. Just to tell you what we're planning in the future, we have our lectures planned to next June. We had 2 in the system, one from William and one from Reaction Engine. Unfortunately, they're both in slight financial difficulties, so we've had to take those out. We had an addition on Wednesday, the 4th of June. Rick Parker, who used to be with Rolls-Royce, has come to us and volunteered that he has a a lecture from Concorde to Booms, Supersonic and the Future. Boom is an interesting operation, of which there are many opinions, but Rick Parker will give us the latest up to date because he's working with Boom, I believe. The other one was David Lupalai, who some of you know, who was with public relations initially with Airbus, and he was with Airbus for many years, having come from the UK, and he has created his own presentation about the early days of Airbus, which I think will be quite interesting. But he's well aware, he says, that he can easily drop out if we have another more interesting one. I know some of people will know Mark Allen, who's the head of R&T for Airbus. He said he's can come and talk to us at some stage. So there are other people in the system, so there may be some changes in the future. So the next one we have is still not quite organized. That will be the Christmas lecture given at the IST International School, organized by what? Oh, yeah, Gisela. Oh, no, I just yes, indeed. But Gisela hasn't quite been able to confirm that yet. But the one which is certainly confirmed is on the 22nd of January, which will be our annual Gordon Call lecture. And it's done by Yannick Melange, who is the head of safety of Airbus, which many of us have known for many years. And our current chairman of the Royal Aeronautical Society in London is coming along. That's David Chin, who again, some of you know, who's been a civil servant. He has wide experience in the industry, and he will be gracing us with his presence. Anyhow, so that's, as I say, what we plan to in the future. And just to go on to remind you, we have a branch membership where we have an online section, which we encourage people to use. And it's really a sort of, it's really an act of faith to help us within the, because we can't offer too much. However, Gisela is going to set up some, as she has in the past, some visits to local industry, and that will be only open to people who are members of the Toulouse branch. It costs a fine €10 per annum, which has always been the case since the branch was formed a few years ago, and there's no plan at the present moment to change that. But of course, if you wish to become a member of the Royal Aeronautical Society in London, you can do, but the prices are slightly higher. However, for students, they can have a free membership, and as long as they're studying at the university, and if you see that it's students, and in brackets, aerosociety.com, and that does work. You can go to that, and students will be able to join as a student, as long as they're at university for free. And it gives a number of advantages because there's a lot of digital information. In fact, at the National Aerospace Library, there's a huge amount of information there. Besides, also there's career guidance for those of you who wish that. And also we have the Aerospace magazine, which is an extremely good magazine. Many people in the past said, well, I've given up my other commercial magazines because there's so much in the Aerospace magazine, they've become redundant. So that's a big advantage of being a member of the society. So to remind you, we do have our own website, which is managed by Gisela, and that has links to the aerosociety.com. We also have links to the Académie de l'Air et Espace, and also to the 3F. We have had combined lectures of those in the past, and we may also decide to do those in the future. So thank you very much indeed to Jens, of course, for a very interesting and superb introduction to the A320. And I hope people have been enthralled by that, as many of us have here. Thank you very much indeed, James.